Okay, this is video number 5. It goes along with lesson 11.4 in your book. Last time we talked about inscribed angles and the fact that if you have an inscribed angle where the vertex is on the circle, you follow it out and you take half of the intercepted arc. So if that was 100 degrees, then your inscribed angle would be 50 degrees. Okay, we talked about that last time. 11.4, we're going to break into two different sections. So this is the first video that goes along with 11.4, and it finishes up all the angles. So far we've talked about when angles are, the vertex is on the circle. So now we're going to talk about when the vertex is either outside of the circle or inside of the circle. And all of these are formed by either tangents or what's called a secant, which we haven't talked about yet. So if you remember, a tangent is a line that intersects a circle in exactly one point. Okay, a secant is a line that intersects a circle in exactly 2 points. Okay, so this line would be considered a secant. All right, and if you'll notice, it does contain a chord. So we've talked about chords before. So what we're going to do is have some combination of tangents and secants drawn, and then the rule to figure out the angle measurement. Okay. And as we said last time, we had an inscribed angle where the vertex is on the circle. You follow it out and you take half, so half of 100 degrees would be 50 for that inscribed angle. The next case is, now if you look at this angle formed by two secants, you've got your vertex outside of the circle. So the rule on that is, if you'll notice, if you follow it out, you've got two different intercepted arcs. Okay, you've got a 20-degree arc and an 80-degree arc. Well, the rule is, and these are actually theorems, but you subtract the two intercepted arcs and take half. Okay, so it would be 80 degrees, subtract 20 degrees, and then divide it by 2, or take half. So 80 minus 20 is 60, and half of that would be 30 degrees. So the measurement of angle 1 would be 30 degrees. Okay, and you would do that anytime the vertex is outside of the circle. You subtract the two intercepted arcs and take half. Okay, so we've had vertex being on the circle, you just take half. Outside of the circle, you subtract and take half. And in the last case is if the vertex is inside of the circle, which you will see on this picture. Okay, so if you'll notice, you've got two secants that intersect inside the circle, and there's our vertex, and we're trying to figure out the measurement of angle 2. Well, we still have two intercepted arcs. If you follow it out, we've got 80 degrees here, but you also have 20 degrees here. But unlike the last example where you subtract, you actually add the two angle arc measurements and divide by 2. So in this case, instead of 80 minus 20, it would be 80 degrees plus 20 degrees, which is 100. And then take half of that, the measurement of angle 2 would be 50 degrees. Okay? As well as this angle, since they're vertical. Okay? I want to show you one example, and this comes off of the study guide 9.6 worksheet that you guys have. And sometimes students have trouble with this particular one, so I wanted to go through this one to give you a little heads up on it. But this one has your vertexes outside of the circle, so the rule is you're supposed to subtract your two arc measurements and divide it by 2, and it's supposed to give you 50 degrees. Well, I've got an X here, but I don't have anything outside. Okay, well, all of this is the rest of the circle, since we have two different tangents. We have the inside part here, and the part out here would be the whole 360 degrees minus the X. So you're actually going to have to do a little bit of algebra on this one. So your formula or your equation would be 360 minus X divided by 2 and set it equal to 50. So let me write that out for you. So the intercepted arc was 360 minus X. Was this one? Minus the other one, X, and divided by 2, and you know that would have to equal 50 degrees. And then you could just solve that algebraically to figure out what X would be. So I wanted to give you, to go over that one to maybe help you out when you do that worksheet. Let me see here. I think that is everything for this lesson. Yep, I believe it is. So the next lesson will be the second part of 11.4. And that will be dealing with segments. So it'll be the same pictures, but instead of working with angle measurements, we're going to be working with segment lengths. Oh yeah, the other thing I was going to mention is after we finish the worksheet there, you've got another worksheet to do the big picture worksheet. And if you'll notice on that one, ooh, isn't that pretty? Look at all those angles, all 36 of them. And you will have something similar to this on your test, but it's a little overwhelming to start with. A couple suggestions is try to get all of the arc measurements first. So try to figure out all the arc measurements, and then you can start working your way around answering or figuring out the angle measurements. And you can use stuff from this lesson. You can also use previous things like anything we've done with angles, like supplementary angles. Linear pairs have to equal 180. Triangles have to equal 180. Vertical angles are congruent. Quadrilaterals equal 360. Pentagons equal 540. Okay, so everything we've talked about all year long dealing with angles is fair game to use on a worksheet like this, okay? So I wanted to mention that as well. And we'll see you next time for the rest of 11.4, which will be on segment lengths.